Okay, it'll have this example. Oh, that's okay. That's okay. Yeah, she'll be fine. I already gave her her work. Okay, so we missed that first example in the podcast. Now let me just go back and highlight the difference between that one and this one again. Not for the podcast, but just for you guys. Here, it was opposite signs and the same coefficient, that invisible one in front, so they automatically dropped out. If you have that with the opposite signs, you're good to go. You just add them together. In this one, notice, first of all, these don't have the same number in front. The C's have the same number, but they're not opposite signs. If I put these together, they're not going to cancel out. It's going to become 12C. And then I have 12C plus 5D. I haven't gotten rid of anything. Here's where we do subtraction. If a variable has the same coefficient in front, but they have the same sign, they're not going to cancel out. Now, again, we did this a few chapters back, except when we did it, it just didn't have the equal. It was just doing this. We are going to subtract the whole second equation. Think about that this means we add the opposite. Please do this step because otherwise I guarantee even the best math students forget to flip the sign when you get to the after the equal sign. Even I forget sometimes. So let's add the opposite. I change subtraction to addition, and I come in and I flip all the signs of that second equation. And now, notice what happens. The 6 C's now have different signs. Now I'm back to addition, and I'm just going to add or combine the like terms. Negative 15, now we're on plus negative 12, negative 27. 7D, now it's plus 2D, so that's 9D. 6C plus negative 6C, they cancel out, they're gone. And now I can solve for D. 9D equals negative 27, divide both sides by 9, and I get D equals negative 3. Make sure you're watching out for your positives and negatives. Negative divided by positive makes a negative. Here's my first answer. I take my D equals negative 3, and I plug it back into one of the equations. I'm going to go with the top one just because it's cleaner. On the bottom one, I did my add the opposite. It looks a little messy. You might get confused on, wait, what signs do I use? So I'm going to say just choose the one that looks simpler to work with. For me right now, I'm going to choose the top one. 6C, I still have that. Plus 7 times D, well now I know what D is. It's negative 3. So again, I'm going with the one that has fewer changes in it just so I don't make a mistake. 7 times negative 3, negative or minus 21. I leave the C's alone. I'm going to add 21 to both sides first. Don't forget our rules for adding and subtracting with positives and negatives. When the signs are different, we subtract. We keep the sign of the bigger digit. So negative 15 plus 21 makes positive 6. And nice and easy here, divide both sides by 6. C equals 1. There's my 2 answers. You can leave them separately boxed like this, or you can put them in a coordinate pair. If you want to do that, just remember it's always alphabetical order, like this. That's it. Addition, subtraction. Again, just to summarize, if they already have opposite signs, you just combine like terms. If they have the same coefficient and the same sign, you change one of the equations by flipping all the signs, and then you do the same thing, you combine like terms. That's it. Now, in terms of no solution or infinite solutions, you're not going to see any of those today, but it would be the same thing as before. If you get something that's not true, all the variables drop out, 3 equals 2, no solution. If all the variables drop out, but it's true, infinite solutions. But today they're all going to have solutions. Okay? And that's it. A nice short little podcast, since I forgot to record.